Kia ora. This video is the second one on the practice task for level 2 trig of Hugh's garden. So we've done the first part where Hugh designs his garden and he figures out how much space it will take up. And now he's looking at how to build an extension to the garden, and that extension has to be 25% of the original area. So the area of A, B, C, D was 487.79 meters squared. So to get that, go back and watch the first video. 25% of that will be 0.25 times this, which is 121.95 meters squared. So you could call that 122, I think that would be fine. So he's going to have to build an extra bit. And as I said at the start of the first video, we're asked to do 2 alternative designs. So I'm going to show you how to do one and then give you a practice one to do yourself. So the first thing that's a kind of easy thing to do is to think, well, let's just make it that he builds on an extra triangle bit. I guess there's no reason that he couldn't just whack on a square, which would be fine, except the square won't be at quite the right angle, right? Because here, I'm going to do a triangle, which was what I had planned. The reason I'm going to do the triangle is if I just extend this down, let's just make that line up a bit. So we put this on here. We know if that bit there is 85 degrees, that this has got to be 95 degrees. So this is what point on the thing are we? This is B, C, D, and that's A up here. I'll call this bit down here, the end of the triangle, let's call that F. And then we're going to join this up to here somewhere. So we've got to decide how far along that line do we need to go to get this much area. So we'll just whack that line in there so we get the idea, and then we're going to figure out the dimensions. And that turns out to be pretty easy to do, right? Because, so we'll call this point G. And no, I'm not going to do that, because that way I've got to find 2 new things, right? So I'm going to do something even easier. I'm going to extend out that side, right? The reason I'm letting you hear my thinking is because, like, there's lots of options, right? So I'm trying to pick an option that's reasonably easy. But this time, instead of stopping at a point there, I'm just going to take up that whole side there. Right, so here, I'm going to use all of that, and that way I know the length of that side of the triangle. And I also know that that angle is going to be 95 degrees. So all I got to do is to take that ruler and draw this in, and then the thing I'm trying to work out is how long does that side have to be to give me an area of that much. So we'll call that point there F. So area of that little triangle, FDC, has to be equal to 121.95 degrees. Now we know this angle here is 95. Sorry, I'm getting too tired. It's 121.95 meters squared, right? Not degrees. So that's my area, and the area is equal to a half AB sine C. So let's clean up the triangle a bit. Let's get rid of some of this, get rid of the circle around there. And we know the side here is 20, so it's going to be a half times 20. This angle is the included angle, and this is the side here. So a half times 20 times, we'll call that side, let's call it X. Half times 20 times X times sine of 95 degrees. Okay, so I'm going to be doing some rearranging, but it's pretty easy rearranging. So it's 121.95 is equal to, well, this is 10, so 10 times this, which is 0.996195 times X. So cleaning this up gives me 121.95 equals 9.96195X. Rearranging, I'm going to divide both sides through by this, and I get X is equal to 121.95 over all of this, which works out to be 12.24 meters. So we can draw that extension properly now. I'll take off all of this stuff here. So if we draw that in, we know that this side here Why is it not going? This side here is going to join up to this side here, and it's going to have the right area. So that's going to be 95 degrees. This is going to be whatever we just said, 12.24 meters, and this side is going to be 20 meters. We don't care about that. It doesn't matter, right? We've just gone out here, we've done that much, and then we've done that much. And we know that that triangle area will have the right amount of 121.95 meters squared. Okay, so now I want you to do a different one. I'm going to do the same idea, but I'm going to get rid of all of this mess. We could have done that triangle with any of the other bits. So I'm going to put the triangle in a different place, and you can practice doing it. So this time, let's extend. Let's get the ruler up. Let's extend the side that's up here and see if you can draw in a triangle of the right area. So extending here, that nice blue pen, and this time we'll join it up to this point down here. Take our ruler and join to there. So it's a different shaped triangle, but same idea. We'll call this point E up here. This is point A. So I want you to pause the video and just have a go and see how you get on. Okay, so I'm going to work through it now, but first I'm going to change my pen color. So we know that this angle here, what's this one? A, B, C, D. So angle DAE, this one here, is equal to 86 degrees, right? Because angles on the line equal 180. And we know AD, one length of that new triangle, is 17 meters. I'll just change the pen. I'm sure some of you are going to hate that rainbow color pen. Okay, so the area has to be 121.95 meters squared, and that comes from half of this side, so half of 17 times this AE side, which we're going to label just Y. So it's a half of 17 times Y times sine of 86 degrees. Now when I work that through, what do we get? Let's have a look. I just find my working, because I did this before the video. Well, we get 121.95 is equal to, so this times this gives me 8.479294Y. You could round a little bit more than that, right? But that's what comes out of your calculator. So that tells me the length of that side. Is that right? So Y is equal to 14.38 meters. And we can mark that on. So now we could draw that extension with these dimensions written on it, right? So you draw that triangle in and explain. So the extension could have lengths. Let's see, what did we have? So we had this one here, and then we've got to have it to here. So this length here, AE, AE equals 14.38 meters, and angle, what was the angle? DAE is equal to 86 degrees. So you get the idea. So we've drawn in a triangle, and if I wanted to, I could give that third length, and that would actually, thinking about it, that would be a good thing to do, right? Because we've done that one, and we've done that length there, we were told. We've done that angle. But if you wanted some to actually work off these plans, I mean, I guess that line's going to join up anyway, but we could use the cosine rule now to find that side length. Okay, so cosine rule for a side. Then the next idea that I had is I might be able to do some kind of nice curvy thing, which might actually look better in the garden. So I'm quickly going to show you how to do that one, and I'm going to leave you to do the second bit yourself. But the idea that would be quite nice to do here is that if we take our curvy pen, we could do a sector. And we've got 17 meters here, so a sector, remember, looks like this, where we've got the radius here and the radius here, and a curvy bit here and the center here. So if we made this the center of the circle, and we had this length of 17, then I could do some kind of cute little bordery thing like that, and I could draw it as a segment, as a sector. The reason this is really nice is that all I have to do is that I know that that's 17, so I know that that side is 17. If the center is here at A, I just have to work out how big that angle is. And I'm going to do this in radians, so you want to put your calculator into radians now. Now guys, if you're in a class where you haven't learned about radians, you can do this with degrees. But I've done this with my class in radians, so the formula is going to be this, half r squared theta. Now we know that r is 17, so A has to equal 121.95, and that's equal to a half times 17 squared times theta. So all I've got to do is to solve that baby equation for the angle, and the answer is going to come through in radians. So 121.95 is equal to, so it's 289 divided by 2 times theta. That gives me theta is equal to 2 times 100, whatever this number is. And that works out to be, in radians, 0.843945. So that's in radians. We might want to just get a feel for that in degrees. So in degrees, it's going to be 0.843945 times 180 over pi, which is about 48.4 degrees. So looking at that shape there, what we've got is that this has to be 48.4 degrees, and the sector is here, and that's my center. So I might put some words around that to explain. So the extension is a sector, center is at point A, angle is 48.4 degrees, radius 17 meters, and you'll draw a good diagram. So now I want you to try doing that yourself. Put your center here and see what it looks like if we use that side as the radius and we do a different curvy bit here. So this is slightly longer here, so you should expect that the angle will be slightly smaller, and it's going to look like that. So I want you to finish that off yourselves. Pause the video and I'm going to race through it. What you should get is this: 121.95 is equal to a half times 20 squared theta, which gives me 121.95 over 200 is equal to theta. Theta is equal to 0.6095, which is in degrees 34.9 degrees. So it's going to be a sector centered at, what did we call that point? That point is C, centered at C. Angle is 34.9 degrees, and the radius is equal to 20 meters. So there you go. I hope you enjoyed that. There are actually heaps of different alternatives for how you draw that extension, so you might want to play around with some different ones yourselves. Let me know if you've got any questions.